So let's take a look more at derivatives. So we have here the derivatives of trigonometric functions. So we have here, and we have its chain rule version. Just remember, it's possible that the one inside the trigonometric function is another function. So we would have to take note of that. So let's have the following. Let's have the first one here. Number 1, we would have g of x is equal to 2x cubed cosine x. So as we can see here, it's actually a product between 2x cubed and cosine x. So therefore, we have to apply the product rule. Hence, g prime of x here would be first original, that's 2x cubed, multiplied with the derivative of cosine x, which in this case is negative sine x. That's negative sine x plus the derivative now of the first one, that becomes 6x squared times cosine x. So from here now, what we're going to get, we multiply this, we have negative 2x cubed sine x plus 6x squared cosine x. We can leave it as is, but since we are used to having minus, we're not used to having the first term as negative, so we can rewrite that as g prime of x is equal to 6x squared cosine x minus 2x cubed sine x. Okay. So let's have another example. Let's have number 2. We have f of x is equal to sine squared x minus cosine 3x. Take note that sine squared x is the same as sine x squared plus cosine x. So to find the derivative of this, that's different, so we just need to find the derivative of the two terms separately. Hence, f prime of x is equal to, this becomes 2 sine x times the derivative of the one inside. That's the application of our general power rule. So in this case, general power rule and then the chain rule. So in this case, what we're going to have would be that derivative of sine x now would be cosine x. So hence that's 2 sine x times cosine x. Minus here, derivative of cosine is negative sine. There you go. So the derivative of this would be negative sine 3x times the derivative of 3x, which is the chain rule version. So it's the derivative of cosine 3x times the derivative of 3x, which is 3. So therefore, I'm going to have 2 sine x cosine x here. This becomes minus negative 3 sine 3x. This becomes positive, so we have 2 sine x cosine x plus 3 sine 3x. But this can be further simplified by an identity. Therefore, f prime of x is equal to sine 2x plus 3 sine 3x. There we go. So the rest of the items from 3 to 8, will leave that to you for practice. Let's now go here. Let's go to number 1. We are asked to find equation of the tangent line to the curve y is equal to x cosine x at the point x equals 5. So to find the equation of the tangent line, we need to find the derivative first. So the derivative of y that becomes, again, this is a product, so this becomes the original x times derivative, that's negative sine x, plus the derivative of that first one, which is 1, times the original second, cosine x. Hence, we're going to have negative x sine x plus cosine x. Or, we're going to have y prime is equal to cosine x minus x sine x. Therefore, to find the slope, we substitute pi in the value of x, which then becomes cosine pi minus pi sine pi. And we know that cosine pi is negative 1. It's negative 1 minus pi times sine pi, which is 0 here. So we end up with negative 1. So the slope of our tangent line is at negative 1. And the point is at x equals pi. So we need the y-coordinate or the ordinate of the point of the graph or the function value at pi, because that's the point of tangency of our tangent line. So therefore, we need to substitute pi here. So y, if it's pi, that's pi cosine pi. And that gives us pi times cosine pi, which is negative 1, which is negative pi. So therefore, we need to find the equation of the line that has a slope of negative 1 that passes through the point pi, negative pi. So therefore, we're going to have y minus negative pi is equal to negative 1 times x minus pi. This becomes y plus pi is equal to negative x plus pi. So transposing that, we'll have y is equal to negative x plus pi minus pi, and this gets cancelled. Therefore, the equation of the line tangent to the curve x cosine x at x equals pi is the line y equals negative x. So number 2 will be left for you for practice as well. Now, so far, what we've been doing, we're just getting the basic derivative. But there will also be times that when you need to get the derivative of the derivative. So, for example, is that later on you're going to see that we have a function called the position function. And finally, the derivative of this function gives us the velocity function. And finding the acceleration function, another function in physics, is done by getting the derivative of the velocity function, which is already the derivative of the position function. So if that's a bit confusing, we have a function called the position function, usually described as x of t. This is our position function. The derivative of this is known as v of t, which is the first derivative, the derivative of the position function. That's your velocity function. Velocity function. Once we find the derivative of the velocity function, it's like we're getting the derivative of this again. So there, and that's actually our acceleration function. So as you can see, acceleration function. So as you can see, the position function was differentiated twice. And if we're going to differentiate a function more than once, that's what we call a higher order derivative. This one, finding the derivative of the derivative, is called a second derivative. So higher order derivative is finding the derivative again, repeating the differentiation process on the same function. So let's work with that with number 2. We're asked to find all derivatives or the higher order derivatives until the derivative is 0 of this function here. So let's do that. So we have the function f of x is equal to 6x to the 5th plus 3x to the 4th minus 2x cubed plus 8x squared minus 8x plus 24. We need to find all the derivatives of the function, meaning we need to continue differentiating until we get the derivative of 0. So the first derivative, single prime, this becomes 30x to the 4th plus 12x cubed minus 6x squared plus 16x minus 8. Following our basic differentiation rules. Now, if we're going to find the derivative of this again, that becomes our second derivative. And this becomes 120x cubed plus 36x squared minus 12x plus 16. Since we're not at 0, we need to continue again. We need to find out the third derivative. It's triple prime. And this then becomes 360x squared plus 72x minus 12. Now, the fourth derivative is symbolized now like a Roman numeral 4. So that's the fourth derivative of x, and now we're going to have 720x plus 72. Now, the fifth derivative of x can be symbolized like this. Sometimes they use actual number 5. Is now 720. And we're not yet done. So the sixth derivative of x is the one that will make this 0. So finding all the derivatives, we took to the sixth derivative, which is something that has to do with the power. So the highest exponent of the function is 5. And all the other powers are present. That would mean that if you're going to find 6 derivatives to find all the derivatives of this function because it's raised to. So that's the concept of higher order derivatives. Now we look into implicit differentiation. So an equation x squared plus 2y equals 1 is implicitly defined as a function of x, while an explicitly defined function is y as isolated. And not all equations can be solved for the function explicitly like this. That's why we would need a tool for us to be able to find its derivative without rewriting it explicitly. Hence, we call it implicit differentiation, finding the derivative of implicitly defined functions. So this is differentiation is taking place with respect to x. This implies that when the term involves y, the chain rule must be applied because it is assumed that y is defined implicitly as a function of x. Let's have a specific example, just like number 1 here. So in number 1, we have x to the 6 minus 2x is equal to 3y to the 6 plus y to the 5th minus y squared. Since we cannot define it as y equals something, we'll do just implicit differentiation. What's the difference between the usual differentiation? Since there is a y term, it has to be written explicitly that it's a y, that y is a derivative in terms of x. It's an x term as is. If it's a y term, we have to write either y prime or dy over dx, which is the more usual one, dy over dx. So let's apply it in number 1. Since this is an x term, the derivative of this will just be the same. It's 6x to the 5th. Well, this one, the derivative is just the same, minus 2. However, for the y terms, it will be different. We'll do the same constant multiple and then power rule, so this becomes 18y to the 5th, but we need to add either y prime or dy over dx. Because this is the one that indicates that y is implicitly differentiated. That y is differentiated in terms of x. So, we're going to do exact same thing with the others. This becomes now 5y to the 4th dy over dx minus 2y dy over dx. Then, for us to be able to find an expression, we need to solve for dy over dx. In this specific case, it's quite easy. We can factor it out on the right-hand side. So, we copy the left-hand side. 6 to the 5th minus 2 is equal to dy over dx times 18y to the 5th plus 5y to the 4th minus 2y. Then now, we now divide both sides by 18y to the 5th plus 5y to the 4th minus 2y. 18y to the 5th plus 5y to the 4th minus 2y. Therefore, the first derivative of the equation in number 1 becomes 6x to the 5th minus 2 all over 18y to the 4th plus 18y to the 5th, 2y to the 5th plus 5y to the 4th minus 2y. So that's an example of implicit differentiation. Let's have another example, the number 2. Let's have it here. Number 2, we would have 3x to the 4th y squared minus 7xy cubed is equal to 4 minus 8y. Now that the x and y terms are together, that's considered to be for product rule. So let's find its derivative. I'll factor out 3 here first so that it will not be that confusing. And then it's x to the 4th y squared that I'm going to find the derivative. So first, the derivative of the first one, that's 4x cubed times the original second, plus the original first, x to the 4th, times the derivative of the second, which is 2y dy over dx. Going to do the same thing here. That's minus 7 factored out, and then the derivative of the first, which is 1, so that leaves me with y cubed, plus the original first, plus times the derivative of the second, which is 3 times 3y squared dy over times 3y over dx is equal to the derivative of 4 is 0 and it's negative 8y. So the derivative of that is negative 8 dy over dx. Let's simplify stuff. First, let's multiply this one here. So I'm going to have 3 times 4x cubed y squared plus 2x to the 4th y dy over dx minus 7 times y cubed plus 3xy squared dy over dx is equal to negative 8 dy over dx. Then we distribute now what needs to be distributed. That's 3 and negative 7. So I'm going to have 12x cubed y squared plus 6x to the 4th y dy over dx minus 7y cubed minus 21xy squared dy over dx is equal to negative 8 dy over dx. We combine like terms. We place all the terms with dy over dx on the left hand side and those without on the right hand side. So those without, this one, are all go to the right hand side while this goes to the left hand side. So what I'm going to have would be 6x to the 4th y dy over dx minus 21xy squared dy over dx plus 8 dy over dx, since it's been transposed, is equal to negative 12x squared x cubed y squared plus 7y cubed. So there. Factoring out dy over dx on the left hand side, we're going to have 6x to the 4th y minus 21xy squared plus 8 is equal to negative 12x squared y plus 7y cubed. So now, dividing both sides by 6x to the 4th y minus 21xy squared plus 8, 6x to the 4th y minus 21xy squared plus 8. I'm going to interchange this so that it looks positive. Therefore, the derivative of number 2 is actually 7y cubed minus 12x squared x cubed y squared all over 6x to the 4th y minus 21xy squared plus. So again, that is implicit differentiation. Finding the derivative if the equation of the function cannot be explicitly given.